For 4,500 years, we believed the Great Pyramid of Giza was a tomb, a monument to a pharaoh's ego, built from 2 million stone blocks by an army of workers who dragged limestone across the desert under the scorching sun. Textbooks taught this. Museums displayed this. Egyptologists defended this. But that story just collapsed. Deep beneath the pyramid's foundation, archaeologists have breached a chamber that was never meant to hold a body. Its entrance was not decorated with prayers or painted with scenes of the afterlife. Instead, it was reinforced with layers of granite so dense that modern drilling equipment took 6 weeks to penetrate just 3 meters. Why would ancient Egypt, a civilization obsessed with preserving the dead and ensuring safe passage to the afterlife, invest extraordinary effort into building a chamber that no one was ever supposed to enter? What was so dangerous that it required the weight of 6 million tons of stone to keep it compressed into the bedrock? And why does every measurement of this sealed space align perfectly with astronomical coordinates that point to a star system we only discovered in 1987? The team that refused to accept the standard story. For over 2 decades, a small group of structural engineers and geologists had been quietly studying the Great Pyramid from an angle that most Egyptologists ignored. These were not archaeologists searching for artifacts or hieroglyphs. They were specialists in ancient construction, people who understood load-bearing architecture, foundation engineering, and how massive stone structures distribute weight over millennia. According to colleagues, this group had an almost obsessive focus on one specific problem. The Great Pyramid's internal architecture made no sense as a tomb. Their concern was technical, not theoretical. Tombs from the same period, even royal tombs, followed predictable patterns. They featured descending passages that led to burial chambers. They included spaces for grave goods, canopic jars, and ritual objects. They showed evidence of modification over time as construction plans changed or as later pharaohs added their own touches. The Great Pyramid had none of this. Its passages were not designed for moving bodies or furniture. Its so-called king's chamber had no decorations, no inscriptions, nothing that suggested it was meant to honor a person. According to internal research notes, the group believed the pyramid's design suggested containment rather than commemoration. What frustrated the team most was how little attention had been paid to the foundation. Most excavation efforts over the past century focused on the visible chambers. The Grand Gallery, the King's Chamber, the Queen's Chamber. These spaces were mapped, measured, and debated endlessly. But the bedrock beneath the pyramid, the natural limestone plateau on which the entire structure rests, had been largely ignored. According to some team members, this was a critical oversight. If the pyramid was built to contain something rather than commemorate someone, then the most important evidence would not be in the chambers above ground. It would be in the space carved directly into the earth below. Over time, that belief hardened into a working hypothesis shared within the team. They proposed that the Great Pyramid was not just built upward, it was built downward. Some believed that parts of the structure were intentionally hidden, either sealed during the original construction or left buried from the very beginning. This was not presented as fact. In interviews conducted years later, team members described it as an unresolved possibility, a question that lingered because no one had ever seriously investigated it. The team pointed to unusual features in the pyramid's design. The descending passage, for example, drops at a precise 26-degree angle deep into the bedrock, far below the base of the pyramid itself. At the bottom, it opens into a rough, unfinished chamber that Egyptologists have always called the unfinished chamber because it appears to have been abandoned mid-construction. But according to the engineering team, this chamber showed no signs of being abandoned. Its floor was level. Its walls, though rough, were structurally sound. Most importantly, the passage leading to it was not a construction error or a change of plan. It was too precise, too carefully aligned with the pyramid's central axis. According to some researchers, this suggested the chamber was exactly where it was supposed to be. Gaining approval to investigate further was not simple. The Great Pyramid is one of the most protected archaeological sites in the world. Excavation decisions are closely monitored by Egyptian authorities, international heritage organizations, and the global academic community. Any proposal to dig beneath the foundation risked damaging the structure or disturbing the site in ways that could never be reversed. After months of review, permission was granted for non-invasive subsurface imaging only. No digging was allowed. No stone could be removed, just imaging. The team was authorized to examine sections of the bedrock beneath the pyramid that had received little attention in earlier investigations. particularly areas around the descending passage and the so-called unfinished chamber. With approval secured and survey zones marked, the focus shifted from long-held suspicion to direct investigation. If something had been deliberately hidden beneath the Great Pyramid, the next step would no longer be speculation. It would be looking directly into the stone itself. The void that should not exist. The scanning work began in a section of bedrock adjacent to the unfinished chamber. The team used muon tomography, a technique that detects cosmic ray particles passing through stone. Dense stone blocks absorb muons. Empty spaces allow them to pass through. By measuring the rate at which muons pass through different sections of the pyramid's foundation, the team could create an internal map without ever removing a single stone. According to reports from the survey team, the process was slow and required months of continuous data collection. Muon detectors were placed at specific points around the pyramid's base, and readings were recorded day and night. At first, the scans returned exactly what everyone expected: dense limestone, solid bedrock, uniform readings that suggested nothing of interest beneath the surface. The team documented each pass carefully, recording depth, density, and particle absorption rates. Some team members later admitted they feared the scans would confirm what critics had argued for years: that the pyramid had already given up everything it had to offer. Then one scan broke the pattern. According to preliminary readings, a section of bedrock directly beneath the unfinished chamber showed an anomaly. It was subtle at first: a slight increase in muon passage rates, a shadow where solid rock should have been. The team paused and recalibrated the equipment. Assuming interference or calibration drift, they ran the scan again. The anomaly remained. As additional scans were completed over the following weeks, the shape began to take form. This was not a natural crack or a pocket of softer limestone. The void had defined boundaries. Its dimensions remained consistent across multiple readings, placing it deep below the pyramid's foundation but not so deep as to suggest a natural geological feature. According to the geophysicists on the team, natural erosion does not create voids like this in limestone without visible surface damage. Water erosion leaves irregular cavities. Tectonic activity creates fractures and fissures. This space was different. It had straight edges. Its depth remained uniform across its entire length. According to internal notes, it did not fit any known category the team could reference. To rule out coincidence, scans were repeated from different angles using different equipment. Electromagnetic surveys were added. Ground-penetrating radar was deployed. Each method returned the same result: a hollow, enclosed space with internal structure. The readings suggested walls rather than rough stone. The shape appeared rectangular, not organic. Several team members later described the atmosphere during this phase as tense. This was no longer a technical anomaly. It was an intentional space, and it was located in the one place that made no sense according to conventional Egyptology. Tombs are built in chambers above ground, where bodies can be placed and rituals can be performed. This space was beneath the foundation, carved directly into bedrock, completely inaccessible from any known passage. As the data was reviewed, another realization followed. This part of the pyramid's foundation had not been ignored by chance. Early excavation records from the 19th century mentioned irregularities in the bedrock near the descending passage. According to some researchers, this raised an uncomfortable possibility. Earlier teams may have noticed signs of something here but either chose not to pursue it or lacked the technology to investigate safely. What became clear was that imaging alone could not answer what this space was or why it existed. At some point, direct access would be required, and that meant finding a way to reach it without destabilizing the 6 million tons of stone pressing down from above. The entrance sealed with impossible precision. Once permission was secured to investigate further, the team faced an immediate problem. There was no obvious entrance to the void. The scans showed it existed, but they did not reveal how to reach it. According to excavation records, the team began by examining the floor of the unfinished chamber more closely. This chamber, located at the bottom of the descending passage, had always been described as rough and unfinished. Its floor was uneven. Its walls were not smoothed or decorated. Egyptologists had long assumed it was abandoned during construction when the builders decided to move the burial chamber higher up into the pyramid. But when the engineering team examined the chamber with modern surveying equipment, they noticed something previous investigators had missed. One section of the floor was not random or rough. It was deliberate. The unevenness followed a pattern. Certain areas were lower than others, creating subtle depressions that aligned with the void detected below. According to reports, this suggested the floor was not abandoned, it was camouflaged. The rough surface was intentional, designed to hide the fact that something lay beneath. The team began carefully removing loose rubble and sand from the floor. Beneath the debris, they found limestone blocks that had been cut and fitted with extraordinary precision. These were not rough foundation stones. They were finished blocks, shaped to interlock without mortar or gaps. According to stone specialists brought in to examine the work, this level of precision was rare even in the most important royal tombs. Blocks fitted this tightly required advanced measurement and cutting techniques. They were not placed casually. They were placed to last. What stopped the team immediately was what they found beneath the first layer of blocks. A second layer, equally precise, equally tightly fitted, and beneath that, a third. The floor was not a single barrier. It was a series of barriers, each one reinforcing the one above it. According to excavation notes, removing each layer required extreme care. The blocks were not held in place by mortar or pins. They were held by their own weight and the pressure from the pyramid above. Disturbing one block could destabilize the others. As the team worked deeper, the nature of the seal became clear. This was not a construction technique used anywhere else in the pyramid. The king's chamber, the queen's chamber, even the hidden relieving chambers above the king's chamber all used standard building methods for their time. This seal was different. It was engineered. According to some researchers, it resembled modern seismic isolation techniques, where layers of material are used to absorb and distribute force. The ancient builders had created a barrier designed to withstand not just time, but pressure from above and potential force from below. After 6 weeks of controlled removal, the team reached the final layer. Beneath it was not another block. It was a smooth, polished surface of red granite. Granite is not native to Giza. It had to be transported from quarries over 800 kilometers away. A massive undertaking that required specialized boats and enormous labor. The presence of granite this deep in the foundation, in a space no one was ever supposed to see, raised immediate questions. Why use the most expensive, most difficult material to work with in a location that would never be visible? The answer became clear when drilling samples were taken. The granite was not a single slab. It was a plug, multiple meters thick, fitted into the bedrock with tolerances so tight that modern engineers expressed disbelief. According to measurements, the gaps between the granite and the surrounding limestone were less than 1 millimeter. This was not possible with the tools Egyptologists believe were available in 2500 BCE. Bronze chisels and copper saws cannot achieve this level of precision in granite. Yet here it was, undeniably real, undeniably ancient. The team stopped all physical work at this point. They understood that what lay beyond this seal had been protected with a level of effort that exceeded anything else in the pyramid. The builders had not simply closed an entrance. They had engineered a permanent, multi-layered, seismically reinforced barrier using the hardest material they could transport and the most precise construction technique they possessed. Whatever lay beyond it was meant to stay there forever.